All right, welcome back, Hononegah. Honors Algebra 2, Section 6.3 is on logarithms and logarithmic functions. This is a very, very important section as we go through the rest of the chapter. So here we go. You know that 2 squared equals 4 and 2 cubed equals 8. However, for what value of x would 2 raised to the x equals 6? Mathematicians define this x using a logarithm. So x equals log based 2 of 6. So this is a very, very important section to talk about right here, is that if you have x as an exponent, so b raised to the x power equals y, the b is the base, x is the exponent, y would be what it would equal, or the argument. So the logarithm of y. So this is how this is switched into a logarithmic function. Log based b of y would equal x. So again, logarithms are exponents. And the more you understand that a logarithm is an exponent, the more you'll understand some of the rules that go along with logarithmic functions. So a log equals the exponent of the base. So log base b of y would equal x. So I just want to rewrite. I want to go from exponent form to logarithmic form because sometimes it's easier to solve something in logarithmic form and sometimes it's going to be easier to solve things in exponent form. So I call this the spiral method. This is the base and that's the exponent of the base. So 6 raised to the third would equal 216. So again, 7 raised to the 0. The base 7 raised to the 0 power equals 1. And again, sometimes I refer to that as like a spiral method. So 7 raised to the 0 equals 1, or 21 raised to the first equals 21. Well, let's go the other way. Now I have something in exponent form, and this is where you're going to do way more often, is log base 9 of 81 would equal 2. Remember, logs equal exponents. So log base 16 of 8 would equal 3/4. Again, logs equal the exponent. Log base 15 of 1/225 would equal -2. So again, logs equal exponents. Now, there's some special ones that you should know about, special logarithmic function. Anytime you have a log equaling 0, it doesn't matter the base. Think about that. Log base, because anything, it doesn't matter what it is, raised to the 0 power is going to equal 1. So log based b of 1 is always going to be 0, because anything to the 0 power equals 1. I'm having smartboard issues. Sorry about that. So this situation right here will always equal 0. It's log base b of 1. Another situation that, all right, I'm back there. I was having issues. So it is working now again. Just a reminder of what we just talked about, and I know we already did it, but anything log base b of 1 will always equal 0. Next one, if you ever get a log with the base and the argument as the same, so log base 3 of 3 or log base 7 of 7. The only way to get that, it would be if the exponent was 1. Think of that. B to the first would equal B. So again, these are some special situations. You ever run across anything raised, anything with the argument of the same base, it's always going to equal 1. All right, time to start. Right now it's in logarithmic form. And I want to solve this. I want to know what x equals. And so I'm going to change this into exponent form. So 4 to the x equals 256. Now, for our purposes here, I want to try to get the bases to be the same. So if I have 4 raised to the x, I want to change 256 into 4 to the something power. Okay? And so what would 4 times 4 times 4 times 4 be? And so 4 to the fourth is 256. Okay, and this can get a little complicated, but we're going to get x to equal 4. If the bases are equal to each other, then the exponents must also be equal to each other. Now, so if I set this to the x power, this one's a little bit more complicated. how do I, in the world, am I going to do 0.125? Well, as a fraction, 0.125, 0.125 is 1/8. Now, an eighth can also be written as 8 to the negative first power. So all I did was change that value into getting it the same base then. And so then x would have to equal -1 in order for that to be true. Fractions are another one that's a little more challenging. 1/3 x equals 27. What I would say most of the time is change it into positive. So that's 3 to the negative x, and this is 3 to the third. And so negative x must be 3, so x would equal -3. Next one, 64 to the x power will equal 8. Now, you can't square one side, but I can change 64 into 8 squared. And so now the bases are the same. I can set them equal and solve. So again, the object of this is to change it so the bases would be the same, and once the bases are the same, the exponents then must be equal. Now, with that said, I highly recommend you breaking them down into integers greater than 1. So if you have a fraction, I would change it into something that's not a fraction. Common logarithms is the logarithms base 10. If you look at your calculator right now, you'll see a log button. Okay, and natural logarithms are actually based E. Okay, so on a calculator, when you just see log, it is automatically considered base 10. Or if you see an LN button, that's actually a log with a base of E, natural log. So let's use our calculator right now. Let's pull it out. So we're going to do log of 21, and I want to round this to 3 decimal places. So pulling out a calculator. Log is located on the left-hand side. So log 21. Enter. 1.322. So my answer to log of 21 is 1.322. Natural log of 0.54. So going back to the calculator, natural log is also located on the side there. And so natural log of 0.54, hit enter, negative 0.616. So finding out where the natural log button is on the calculator. Some special ones. By definition, a logarithm is the inverse of the exponential function. The following can be proven. Log base b of b equals x. Again, this is a special situation. If you ever have a base of the same number raised to an exponent, then that exponent will always be the answer. Think about this now. If I did b, or base 3 raised to the 4th, it would have to equal then 3 to the 4th. So if you ever have a situation in which you have a base raised to the same argument, so again, going back to kind of what we talked about earlier, if it has an exponent, then the answer is that exponent. Now, this one is a little quirky. Base raised to a log base x. Remember, logs are exponents. So this right here is an exponent. And so therefore, because you have an exponent of b, then the answer is just whatever the argument is. So if you ever have a number or something raised to a log of that same number, whatever the argument is, let's say it's 4, is the answer. So again, something raised to a log is the exponent, and therefore the argument of that would have to be 4. And so 7 raised to that log is 4 in that case. All right, so I've got log base 3 of 3 raised to the x plus 1. So the exponent would be the answer. So log base 4. Now, this one's a little bit more complicated. I'm going to change 16 into 4 squared. So now that it works for this particular situation, so log base 4 of 4 raised to the 2x would just be 2x. And again, this is 10 raised to the log base 10 because, again, anything that's not written with a base. So if I have a number raised to a log of the same base, then the argument is the answer. In order to graph logarithmic functions, you need to turn it into exponent form. So this would be, if I did a spiral, and I know it's backwards, 7 raised to the f of x, or 7 raised to the y equals x. And so if I did an xy chart, instead of putting numbers in for x, I'm actually going to put numbers in for y. So what if I put 1 in for y? Then x would be 7. And what if I put 0 in for y? Then x would be 1. And what if I put -1 in for y? Well, I get a fraction. I'd get 1/7. So now, graphing those, 7, 1, 1, 0, 1/7. So it's a graph that goes along the y-axis. Remember we talked about asymptotes. It has a y-axis asymptote. So it doesn't cross the y-axis. Homework assignment tonight, and again, this is going to be fairly basic today. Homework assignment tonight is out of the book. If you have any questions, please make sure you talk to your teacher, and good luck. This is the last lesson before the holiday, so if you're hearing this right before, have a very safe and enjoyable holiday from Miss Kensel and I. And if you have any questions, make sure you reach out to us. But good luck.